Hi everyone, we are Team YOWO V2. Here is our project on towards improving spatial temporal action recognition in videos. Object detection focuses on detecting object location and classification in a given image. Recently, much attention has been drawn to the field of spatial temporal action recognition in videos. Videos, however, are time series of images that consist of both spatial and temporal components. Hence, spatial temporal action recognition requires both spatial and temporal information. YOWO is the first end-to-end object detector. It treats object detection as a regression problem by learning object class probabilities and bounding box coordinates. Recently, an object detector called YOWO uses a 3D CNN to model the spatial temporal features and a 2D CNN branch to extract the spatial features. On the other hand, a recent anchor-free approach called CenterNet detects objects as points by first modeling the center of an object and then uses this predicted center to get the bounding box coordinates. Here, we use two datasets for our project. The first one is a well-trained public data called the JHMDB. Another dataset is a private restaurant data with highly imbalanced object classes, making the task of action recognition more challenging. For our project, we aim to modify the YOWO structure so as to increase action detection precision and reduce computational time. Also, we aim to deal with the class imbalance issue as motivated by the AGA dataset. Specifically, we are proposing the below several novel architectures. The first architecture we propose is called the LinkNet. In the YOWO, focusing on the middle part, the 2D CNN and the 3D CNN backbones do not have interaction during feature extraction. However, the spatial temporal features of previous frames are highly related to the spatial features of the keyframe. So we propose to modify the middle part by adding a linkage between the 2D CNN branch and the 3D CNN branch by adding several interaction layers between them. The second approach is to predefine bounding boxes before chaining, which are called anchor boxes, and adjust these boxes with the ground truth bounding boxes during chaining. YOLO V2 computes anchor boxes by k-means clustering, achieving a better result than the original YOLO, where no anchor boxes are used. Following a similar idea, we propose to compute candidate anchor boxes using k-means for the YOLO. The third architecture we are proposing is called Center 3D, which is a two-stage anchor-free structure. An image is fed into a pre-trained CenterNet for localization, and then a heat map is generated by presenting the object as multiple points. We create similar heat maps for each frame in a video clip and feed these heat maps into a 3D CNN for object classification. Then, to address the class imbalance issue in the AGA dataset, we propose to modify the classification loss function by reweighting the focal loss with effective number of object classes. Here are the results on the JHMDB. We try LinkNet with several linkage variation and the Center 3D. LinkNet suffers from a very low classification accuracy, which is because the 2D features blurs the information in 3D CNN after adding the link layers. The Center 3D, however, has a very good recall in a short training time. Here are some visualization results on the JHMDB. Here are the results on the AGA dataset. Compared to the baseline, we see the YOWO model with a DIY anchor box has a very good accuracy as well as satisfying frame MAP. The ENF loss, however, failed to perform well in terms of classification and frame MAP. Here are some visualizations on the AGA dataset. In summary, we have proposed 4 methods in attempts to improve YOWO and imbalance class issue as motivated by our real data. DIY anchor box and the Center 3D perform quite well among the proposed methods. Our project has several limitations. Because of the time and resource limit, we failed to run the Center 3D on AGA data. Also, pre-trained models were used in the Center 3D. For the ENF loss, more fine-tuning on the hyperparameter is needed to achieve a better result. We may also try combining our proposed methods while modifying the loss function for future works. And here are our main references. Thank you very much for listening.